So what we're going to do with this graph is basically sketch it, and we're going to sketch that, we have to find our critical points, we have to find our inflection points, asymptotes, our symmetry, our domain, x and y intercepts. We're going to do all of that. So let's do that real quick. So to start off, first step is just take the first and the second derivative, and that way we can find our critical points and we can find our inflection points. And that'll help us determine our domain. So if we take y prime, which is the derivative of that, we get 4 times 3x cubed plus 3 times 4x squared, right? This just equals 12x cubed plus 12x squared. Then we get y double prime. We get the derivative of this. So we get 3 times 12x cubed, or not cubed, rather squared, plus 2 times 12, just x to the first, which equals 36x squared plus 24x. Now, what is a critical point? So when this equals 0, that's a critical point. So this is what a critical point means. When your first derivative equals 0, that means your slope is equal to 0. So if you have this graph right here, at a certain point, you're going to have a slope of 0. When that slope is 0, we call that f prime of c is equal to 0. Because f prime is just your first derivative, c is just some number, or some x, and then it's equal to 0 because your slope is 0. So that's your critical point. When this equals 0, that's called an inflection point. So what does an inflection point look like? So if you have this graph right here, like this, at this point right here, this graph, after this point, the graph is pointing upwards. Once it reaches this point, the graph is going to start pointing downwards. And once it points downwards, that's a concave change. So over here, this is concave up. So this is right here, concave up. So that's when y prime is greater than 0. So it's positive. This right here is concave down. So y double prime is less than 0, or it's negative. And that is your inflection point. So that's what that means, right? And I think it's good to point that when the slope is negative, so this is a negative slope, it's decreasing, and our slope is positive, that's increasing. And so that's for our first derivative. So this is y prime, right? So this is important to note. So this will help us in our curve sketching. So we have y prime. So how do we get this to equal 0? Well, when y prime equals 0, that's equal to 12x cubed plus 12x squared. Well, we can factor this. So if we factor out a 12x squared, we divide 12x squared from this, which we get x. If we divide 12x squared from here, we get positive 1. So that's how and if you FOIL this, you'll get the same exact equation. This way, we can figure out how to make this whole thing equal to 0. So if we make this equal to 0, that means that when 12x squared is equal to 0, we just have x equals 0. And right here, when this equals 0, we have x plus 1 is equal to 0. So x equals to negative 1. So these are our two critical points. So like I said before, for our critical points, these are our two critical points. I'm going to write CP. Now, for y double prime equal to 0, that's equal to 36x squared plus 24x. So let's go about factoring out this again. So we can factor out a 6x from this. So we say 6x, and then times, if we divide 6x by this, we get 6x. If we divide 6x by this, we get plus 4, right? This all equal to 0. So when this equals to 0, we have 6x equal to 0, so we have x equals 0. So that means x equals 0 is an inflection point. When this equals 0, you get 6x plus 4 equal to 0. So 6x equals negative 4. So x equals negative 2/3. That's when you simplify. So these are our inflection points, right? These will also help us determine our domain, like I said before. So if we look at just the function y right here, x can be anywhere from negative infinity to infinity. There's no asymptotes here because we're not dividing by an x over here. There's no horizontal asymptotes because as x goes infinity, y also goes infinity. So we don't have to deal with that. Now, because x is in between infinity and negative infinity, right? Now we have to basically narrow down our scope to these points. So our first point is at x equal negative 1. So if we say from basically negative infinity, right, to negative 1, right, that's our first interval. And then we're going to look at x equals negative 1, right? Then we're going to look at our next interval, which is negative 1 to our next number, which is negative 2/3, right? And I'll put that as a bracket because we're actually evaluating it. Then we're going to look at x equals negative 2/3. Then we're going to do our next interval, which is negative 2/3. And then we'll go to x equals 0, right? And then we'll evaluate x at x equals 0. And then our final interval is basically 0 to infinity, right? So we have to evaluate 1, 2, 3, 4, 5, 6, 7 things here, all right? Our intervals are going to tell us whether the function is increasing, decreasing, etc. And our points are going to tell us whether these are relative maximums or relative minimums because they're either inflection points or they're critical points.